So this is part 3, our third video in our introduction to exponential functions. We have to look at another kind of example, a slight variation on things. We're going to graph f of x equals 1/2 to the x power. So something a little bit different is going to happen here that we got to make sure we understand. And when I write a fraction to the x power, that's exactly the same in this case as writing a decimal to the x power. I could write 0.5 to the x, 1/2 to the x, 0.5 to the x mean exactly the same thing. So I'm going to plot points. So let's get a table of values going here. And here's my first x value, 0. And what we're seeing in all these exponential functions is when we take a base to the 0 power, we're always going to get 1, no matter what the base is. Now, f of 1, here my base is 1/2. 1/2 to the first power is half. Anything to the first power is itself. F of 2 is 1/2 to the second power, that's 1/2. Times 1/2, or 1/4. F of 3 is 1/2 to the third power, which is 1/2 times 1/2 times 1/2. So I multiply across the numerator, across the denominators, I get 1/8. F of -1 is 1/2 to the -1 power. And there are a lot of ways. You guys should be familiar with how to simplify this, but one approach would be to write it as 1/1/2 to the 1, which is 1/1/2, or 1 divided by 1/2, which is the same as 1 times 2/1, or 2. In fact, 1 over a fraction is always going to be the same as the reciprocal of that fraction. So really at this point I know I'm going to get 2/1 or 2. So f of -2, there's going to be a pattern here to this. 1/2 to the -2 is 1/1/2 squared, or 1/4. And I know, again, this is just going to be the reciprocal of 1/4, or if I work out the division, 1 divided by 1/4 is 1 times 4/1, or 4. F of -3, 1/2 to the -3 is 1/1/2 cubed, is 1/8, and that's also 1 divided by 1/8. 1 times 8/1, which is 8. So it seems kind of similar to our 2 to the x example, but a little bit different. So let's plot these points that we have. I already set up a graph grid down here at the bottom of the sheet. 0, 1, there's our 0, 1 that we keep seeing over and over again. 1 1/2, 1 1/2, now on this scale, I gotta be about there. 2 1/4, so this looks a little different from what we were seeing before. 3 1/8. So this graph is not taking off to infinity. It's actually, as we go to the right, it's actually shrinking down, getting closer and closer to the x-axis. At -1, I'm getting +2. At -2, my y value is 4. And at -3, the y value is 8. When x approaches -infinity, this graph is actually taking off to infinity. So there are some similarities and some differences to the 2 to the x graph. So remember, this is f of x equals 1/2 to the x. And the main difference here is in the end behavior. We kind of have the reverse of the end behavior we saw with 2 to the x or 10 to the x, right? So as x approaches infinity, f of x approaches 0, we still say the x-axis is a horizontal asymptote, but the meaning of the horizontal asymptote is seen when we move to the right, far to the right. As x approaches minus infinity, the function values blow up. And that's what it means for the graph to be rising up to the left, like so. So let's just what I want to do is summarize this now. And we're going to go back to our sheet we started on the last video, because that was one situation for exponential functions. There's actually two important situations, and we got to understand the difference. So right below here I'm going to write if b is a constant, and similar to what I said up there, but instead of greater than 1, I'm going to say between 0 and 1. So 1/2 is an example of that. Any fraction between 0 and 1 is an inequality. I could write 0 less than b less than 1. Then the graph of f of x equals b to the x looks like. So in the example we just did, the b was the 1/2, right? So I'm going to draw my axes. Here's x, here's y. We're still going to pass through that point 0, 1, same y-intercept, but the graph now is going to be shaped like so. And we're going to approach that x-axis as a horizontal asymptote when x is positive. Domain is the same. All real numbers in both cases. Range is the same. Only positive y values. Y cannot be 0. It's the end behavior that's different. As x approaches infinity, f of x approaches 0. So that's why I'm going to write right here the x-axis is a horizontal asymptote. As x approaches minus infinity, f of x approaches infinity. And I just want to write here f of x equals b to the x, where that b is between 0 and 1. So really this sheet, everything you see in front of you now, really sums up everything we've discussed about exponential functions so far. The difference between these two pictures is b is greater than 1. In the top picture, the base b is between 0 and 1 in the bottom picture. So the graphs are very similar. In fact, one is just a reflection of the other through the y-axis. So I'm going to stop this video here. Next part, there's another part where we're going to do some problems. We're going to do some graphing problems and use the information on this sheet and also some transformations to sketch graphs of functions.